Hi, this is Dr. Heath. I'm here with section 8.2. We're in Math 3322, Math Concepts 2. Today we're going to look at the second section of Chapter 8, all about algebraic thinking. So section 8.2 is about equations. So in this section you should be able to understand and explain properties of equality and equations, solutions of equations using properties of equations, and solutions of word problems. All right, so we have a few properties that are going to be really useful for us when we go to solve equations. So when we have real numbers, and if we have some equation with a equal to b, then we can add a real number c to both sides of the equation and we maintain equality. So if a equals b, then a plus c equals b plus c. We can similarly apply multiplication to both sides of an equation. So if a equals b, then a times c equals b times c. Then we have cancellation, which comes from the fact that we have subtraction and division. So if we have a plus c equals b plus c, then we can subtract c from both sides, and we get a equal to b. And then if we have a, b, and c is not 0, then we can divide ac equals bc, both sides, by c, and we are resulted with a equal to b. So it's really important here that we know that c is not equal to 0 here because we're not allowed to divide by 0. So when we go to solve equations, it can be helpful to think about an equation as a scale, a balanced scale, where we have on one side of the equation on one side of the scale and the other side of the equation on the other side of the scale. And so essentially to keep the scale in balance, you have to add or subtract the same amount from both sides. Same with multiplication. So in this case we have an equation where 2 times 3 is equal to 3 plus 2 times 2. Now this equation is not actually true because 2 times 3 gives us 6, and 3 plus 2 times 2, 2 times 2 is 4, we have 7 on this side. So if this person released their hand, then this scale would tilt towards the 7 because we have more on the right hand side. So actually to make these two equal, we would have to add 1 to the left side of the scale to make them equal. All right, so let's try a few examples. So in the first example, we have x plus the cubed root of 4 equal to 20. So our goal is to solve for x. So what we can do in this case is subtract the cubed root of 4 from both sides of our equation. So when we have the left-hand side is now x plus the cubed root of 4 minus the cubed root of 4. So those two things will add to 0. Cubed root of 4 minus cubed root of 4. And then on the right-hand side, we will just have 20 minus the cubed root of 4. If we look at the second example, b, we have 3x equals x plus the cubed, or the square root of 10. Now we're again trying to isolate x. So our goal is to first get all of our x's together in one place. So if we subtract x from both sides, then the left-hand side is 3x minus x, or minus 1x, right? So we're left with 2 x's on the left. And then on the right-hand side, x minus x is 0. So we're only left with that square root of 10. And to get to x alone, we have to divide both sides by 2, and we're left with x equals the square root of 10 over 2, and that can't be simplified anymore. And then finally, with 4x plus 5x equals 99, we first need to combine our x's. So 4x's plus 5x's gives us a total of 9x's. And we can solve for x by dividing both sides by 9. And we're left with x equals 11, because 99 divided by 9 is 11. All right, so here's that all worked out for you on the slide. Okay, here's one more example. So we have 4 times x plus 3 plus 5 times x plus 3 equals 99. There are a couple of different ways you could go about solving this. One option would be to start by first distributing across each of these multiplications and then combining our like terms and solving for x that way. But a potentially more efficient way to solve this problem, because we have x plus 3 and x plus 3 in our equation, we really just have 4x plus 3 plus 5x plus 3, and that gives us 9x plus 3 if we add those together, because 4 of them plus 5 of them gives us 9 of them. And that equals to 99. Then we can divide both sides by 9. We're left with x plus 3 equals 11, and we subtract 3 from both sides, and we're left with x equals 8. And so like I was saying, the other way you could do this would be to first distribute. So we have 4x plus 3 plus 5 x plus 3 equals 99. We could first distribute our 4 and our 5, so that leaves us with 4x plus 12, because 4 times 3 is 12, plus 5 times x, 5x, plus 5 times 3, 15, equals 99. My 4x plus 5x gives me 9x, because I'm combining those together. And then my 12 plus 15 gives me 17. Is that right? Nope, 27. And that's still all equal to 99. And if I subtract 27 from both sides, I'm left with 9x equals 72. And 72 divided by 9 on both sides is 8. So we get the same result either way, but I think this first way we did it is just a little bit faster. But you do have to be careful to always be working your way from the outside of parentheses to the end. You couldn't do something with the inner part of these parentheses before you take care of that 9, because 9 is applying also to 3. And that's just worked out for you. Okay, so let's take a look at a word problem. We have Bruno with 5 books overdue at the library. The fine for overdue books is 10 cents a day for every book. He remembers he checked out an astronomy book a week before he checked out 4 novels. His total fine was $8.70. How long was each book overdue? So first things first, we want to figure out what is this problem even saying. So if we try to understand the problem here, we know he has 5 books overdue. He checked out the astronomy book 7 days earlier than the 4 novels. So the astronomy book is 7 days more overdue than the novels. The fine per day for each book is 10 cents, and the total fine was $8.70. So we need to figure out how many days each book is overdue. So let's say that we're going to need to give a variable here for the number of days the books were overdue. Now we're going to have 2 different days, lengths, because the astronomy book is 7 more days overdue than the other 4 books. So let's let the variable d equal the number of days one novel is overdue. And that tells me that the astronomy book is going to be D plus 7 days overdue. So to think about how much he's going to owe for fines on these books, for the 4 books that are novels, he is going to pay 10 cents per day, so times D, times 4 for the 4 books that are overdue for the novels. So this is the fine for the novels. And then he's also going to have to pay 10 cents per day for the astronomy book, but the astronomy book is D plus 7 days overdue. And that's equal to $8.70. Now we have to be careful here because the way I've written it currently, 10 is in cents. So we would have to have this equal to a value in cents. So $8.70 is 870 cents. Or we could have written our cents as a decimal of 0.10 to have 10 cents. So you just have to make sure your currency is in the same dollars or cents. So to solve this equation, we're going to need to find D. So if I make some room here, and I'm needing to solve 10D times 4 plus 10 times D plus 7 equals 870. Okay, so I can first distribute my 10 across this addition. So I have 10D times 4, and then plus 10D plus 70, and that's 870 cents. And now what's happening here is just multiplication, right? So I have 10D times 4, or 10 times D times 4, so that's 40D plus 10D plus 7D equals 870. And I can then combine my D terms together to get 50D plus 70 equals 870. Subtract 70 from both sides. And then divide both sides by 50. So that's going to leave me with D equals 800 divided by 50. 800 divided by 50. 800 divided by 50 is 16. So that tells me that the 4 novels are each 16 days overdue, because that's what I had defined my D to be. And then the astronomy book, so the novels are 16 days overdue, and the astronomy book is 16 plus 7, 23 days overdue. Okay, let's look at one more word problem together. So in this small town, 3 children deliver all the newspapers. Abby delivers 3 times as many papers as Bob, and Connie delivers 13 more than Abby. If the 3 children delivered a total of 496 papers, how many papers does each deliver? All right, so again, we need to first understand the problem. The problem asks for the number of papers that each child delivers, and it gives information that compares the number of papers that each child delivers as well as the total number of papers delivered in the town. So if we go back to the problem, we need to figure out a way to represent the number of papers that each child is going to sell. So I know that Abby delivers 3 times as many as Bob, and Connie delivers 13 more than Abby. The only thing we don't really know about relating explicitly to the other two is Bob, because Abby and Bob are related to each other, and Connie and Abby are related to each other. So it will probably be simplest if we take Bob and we say, let's let B be the number of papers Bob delivers. Then we know Abby delivers 3 times as many papers as Bob. So Abby is going to be delivering 3 times B. That's the number of papers Abby delivers. And then we know Connie delivers 13 more papers than Abby. So Connie is going to deliver the number of papers Abby delivers plus 13. So Abby delivers 3 times B, and then Connie delivers 13 more than Abby. So we can nest these representations a little bit. So we know that they all sell a total of 496 papers. So Bob's number of papers plus Abby's number of papers plus Connie's number of papers all equals 496. All right, and now we just need to solve for B, and then knowing B, the number of papers Bob delivers, will allow us to know how many papers Abby and then Connie will deliver. So all I'm doing here is adding. So I have B plus 3B plus 3B plus 13. So I have B plus 3B, that's 4B, plus 3 more B is 7B, plus 13 equals 496. I subtract 13 from both sides, and I'm left with 7. B equals 483. And then I divide both sides by 7, and I would use a calculator to calculate this and have 483 divided by 7 is 69. So Bob delivers 69 papers. So Bob delivers 69 papers a day, which means that Abby is going to deliver 3 times as many as Bob. So Abby delivers 3 times 69, and 3 times 69 is 207. And then Connie delivers 13 more than Abby, so we can add 13 to 207, and we get 220. All right, so Bob delivers 69, Abby delivers 207, Connie delivers 220, and then we can recheck our work and make sure that we have a correct answer by summing these all together. So I would do 7 plus 9 is 16. 1 plus 6, 7 plus 2 is 9, 200 plus 200 is 400. So they all sell a total of 496 papers, which is what we were told in the paper. So, or in the problem. So this works out, and we have solved the problem correctly. That is all I have for you today. So have a great rest of your day, and good luck with your assignments on this section. Let me know if you have any questions.